Hello, Calculus and Vectors class. Welcome back. We are going to try the quotient rule in this lesson. So pretty much any sort of rational function can use the quotient rule. Anything in the form f of x over g of x. Anything that looks like a fraction usually can be differentiated with the quotient rule. Before we do that, though, let's take a problem. Before we learn the quotient rule, let's take this and let's see how we could solve it if we didn't have the quotient rule, because right now we don't. So this problem here, right now, we don't have any rules to do with fractions. So the only way we could do this is we could take 6x plus minus 5. Then we could take that x cubed plus 4, and we can rewrite that as x cubed plus 4 to the power of negative 1. And knowing that, then we could use a combination of product rule and chain rule. Looks like overall it's a product rule problem. Remember, now that we have started to learn multiple rules, we may have to use more than one in a problem. So we have to always look at them and try and figure out what the biggest rule is that we're going to have to use. So overall, this is a product problem. But we can differentiate this part using chain rule. So to do that, let's take f of x and g of x for our product rule. And that would be 6x minus 5 and x cubed plus 4 negative 1. To do product rule, we have to know the derivatives, so we would have to do f prime of x, which would be, in this case, linear, so it would be 6. And for g prime of x, in this case, we have to use chain rule, so we differentiate the outside. That's going to be ignoring x cubed to the 4. That's going to be, the outside would be x to the negative 1. So that's going to be negative 1 x to the negative 2. Instead of x, we're going to leave that inside part the same, x cubed plus 4. And then we multiply by the derivative of the inside function, which is 3x squared. And then plus 4 is a constant, so that just goes away. So now that we have that, now we have the two parts of this, then we could start figuring out our derivative. So in this case, for product rule, it would be f prime of x times g of x plus f of x times g prime of x. And yes, I know that over the course of the last few lessons, that rule has changed a little bit, but the basic principle still stays the same. You take each function and multiply it by the derivative of the other function in our product, and then we add them together. Doesn't matter which way we add them or multiply, as long as we do those two things. Then if we multiply each function by its derivative and we add the two products together, then it should all work out. So let's fill in all this information here. So f prime of x is 6, g of x is x cubed plus 4 to the negative 1. And then we have plus f of x. It's going to be 6x minus 5. And then g prime of x is, that was that other derivative there. By the way, I forgot to simplify this, so let's do that right now. It's negative 3x squared times x cubed plus 4 to the negative 2. So we write that over here. So negative 3x squared times x cubed plus 4 to the negative 2. So now that we have that, let's rewrite these as fractions, because that's really how we want it to look in the end, right? If the original function was a fraction, then our derivative should be kind of looking similar as well. So 6 over 3x cubed to the 4. It's going to be plus, let's see, it's going to be negative 3x squared times 6x minus 5 all over x cubed plus 4 squared. And now, it probably help. We can probably get this looking like one fraction. So let's do that. Let's get them over a common denominator. To do that, we're going to take the first one and we're going to multiply by x cubed plus 4, because then we have the same denominator between both fractions. But to make this equal, we have to do the same thing to the top. And so now, in the next line, on the bottom, we have x cubed plus 4 square. We're just going to combine those two fractions, and that's going to be 6 times x cubed plus 4 plus negative 3x squared times 6x minus 5. And now we just need to simplify the top. So that's going to be 6x cubed plus 24 minus, let's see, that's going to be 18x cubed. Let's see, then plus 15x squared. And all over x cubed plus 4 squared. We combine the like terms and we should get negative 12x squared, sorry, x cubed, minus, sorry, plus 15x squared plus 24 all over x cubed plus 4 squared. So using chain rule and product rule, we can find that, but as you can tell, it gets a little bit convoluted. I'll warn you, the quotient rule usually isn't too much better, but it's good to have that tool in your tool belt anyways, just so you can use it if the situation calls for it. So the way the quotient rule works, if we have a function q of x, which is equal to f of x over g of x, then to take the quotient rule, we're going to take this big long thing here. G of x times f prime of x minus f of x times g prime of x all over g to the x squared. Again, it's not super simple, but it should give you the right answer. So one other thing we should quickly note is that g of x cannot be 0. Just like usual, we cannot divide by 0. So just be aware of that as you're doing these. And by the way, I'm gonna try. I have a link for a first principles proof of that rule. I'm gonna put that in the description. So if you're curious, feel free to go and take a look. It's not the most simple to figure out, but it's there if you want to go and take a look. So now that we have that, let's try a quotient rule problem. So the first one says q of x is equal to 6x minus 5 over x cubed plus 4. So first step, let's break this up into f of x and g of x. Remember, f of x is our numerator and g of x is our denominator. So f of x is going to be 6x minus 5, and g of x is going to be x cubed plus 4. Next step, let's find our derivatives. So f prime of x, for f of x, it's a linear, so we're just going to take the slope, which is going to be 6. For g of x, the derivative, we take x cubed becomes 3x squared according to power rule, and our constant of 4 goes away. So now that we have our bits and pieces, let's put them into our definition for the quotient rule. So q prime of x is going to be equal to g of x times f prime of x minus f of x, g prime of x, all over g of x squared. So next step, now we're going to sub all that information in. So the first part is g of x was x cubed plus 4. F prime of x is 6. Then we do minus f of x, which is 6x minus 5. G prime of x is 3x squared. All over g of x squared. X cubed plus 4 squared. Now we just simplify, and let's see if we can kind of make this look a little nicer. So the first two brackets, we multiply them together. So multiply 6 by the terms in the first bracket. We get 6x cubed plus 24 for the first set of brackets. The second set of brackets, we multiply 3x squared by the terms in the first bracket. So that becomes minus 18x cubed. And then we get plus 15x squared, because remember, the negative on the 5 cancels out with the minus out front. And let's keep the stuff on the bottom in factored form, just because it looks so nice already. And next we just combine like terms. So negative 12x cubed plus 15x squared plus 24 all over x cubed plus 4 squared. So that is the function that represents the derivative of this function up top of our q of x. So just like all the problems we dealt with product rule and chain rule, we can use it in the exact same ways, but now we know a method for differentiating rational functions, ones that have f of x over g of x. Let's try this again with a different function. So in this case, we have q of x, which is 4x cubed minus 7 over 2x squared plus 3. So first step, let's summarize our functions. So f of x and g of x. F of x is up top, which is 4x cubed minus 7. G of x is equal to 2x squared plus 3. And we take our derivatives. That's going to be 4x cubed is going to be 12x squared, and minus 7 is a constant, so it goes away. G prime of x, that's going to be 2x squared, becomes 4x, and the plus 3 is a constant, so it goes away. So now we have that. Let's take our derivative. That's going to be g of x times f prime of x minus f of x times g prime of x over g of x squared. By the way, at this point, I'd like to point out that unlike product rule, with this one, because it's subtraction in the middle, it doesn't work the same backwards and forwards. So with this one, you have to use it in the correct order. Otherwise, it's going to give you a result that does not make sense. So be really careful with this one. So let's plug in our information here. G of x is 2x squared plus 3. For f prime of x, it's going to be 12x squared. For f of x, it's going to be 4x cubed minus 7. And for g prime of x, it's going to be 4x. All over g of x squared. So 2x squared plus 3 squared. Now, all we have to do is simplify the top a little bit, and hopefully this will work out for us. So let's simplify a bit. Expand the first two brackets. We get 24x to the 4 plus 36x squared. Then we get minus 16x to the 4 plus 28x all over 2x squared plus 3 squared. And now we're just going to collect the like terms. So it becomes 8x to the 4 plus 36x squared plus 28x all over 2x squared plus 3 squared. So we could leave it like that, but we also know that we can factor up top. In fact, if you know how to factor any of the other ones that we see here, then you're welcome to do that as well. But usually if we can factor, we factor. So let's common factor out 4x. And we're going to be left with 2x cubed plus 9x plus 7 all over 2x squared plus 3 squared. So for our last problem, it's asking us to differentiate the function 4x plus 1 over the root of 1 minus x. So as you notice, it's a quotient rule problem, but inside that quotient rule problem, there's also a chain rule problem. So as we progress further into calculus, you'll find that there are more combinations of rules, one rule inside another. But usually you have to ask yourself, which is the biggest rule that we're dealing with? And in this case, overall, it's a quotient rule problem. So let's start by writing out the quotient rule definition. So q prime of x is equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared. So to find a derivative, we have to find f of x, g of x, and their derivatives. So let's start by summarizing that information off to the side, just like we always do. So f of x is the numerator, 4x plus 1. G of x is the denominator, square root of 1 minus x, which usually when we're doing differentiation, we don't like square roots. So let's rewrite that right now as an exponent. So this will be 1 minus x to the power of 1/2. Their derivatives for f prime of x, it's a linear, so it's just going to be the slope, or 4. For g of x, now we're going to have to use our power rule to help us out a bit, and a bit of chain rule as well. So for chain rule, we take the derivative of the outside function, which is x to the power of 1/2. So it's 1/2 times our inside function to the power of negative 1/2. The inside function stays the same. And then we multiply by the derivative of the inside function, which is negative 1, just a linear, so it's minus x. So it becomes negative 1 as our slope or our derivative. Or we can rewrite that as negative 1/2 times 1 minus x to the negative 1/2. So now we have our two functions, our numerator and denominator, and we have the derivative, so we can start punching that information in and let's see what happens. So next step, let's plug in g of x, which is 1 minus x to the power of 1/2. Then we have f prime of x, which is 4, minus f of x, which is 4x plus 1, times g prime of x, which is negative 1/2, 1 minus x to the power of negative 1/2. All over g of x squared, which is 1 minus x to the power of 1/2 squared, which just cancels out. Think back to your exponent rules. Power of a power, half times times 2 is just 1, or I can think of it as squaring a square root. So next step, here's where it gets a little bit tricky. Actually, the denominator is easy. Let's just rewrite that as 1 minus x. For the numerator, to get this to work, we have to do a bit of common factoring, and we're going to do something that's maybe not super intuitive, which is we're going to factor out a factor of 1/2 and one factor of 1 minus x power of negative 1/2. Now you're probably noticing that our exponents are 1/2 and negative 1/2, but hopefully you'll see why in just a second, why this works well. So let's common factor out all this stuff. So from the first part, which is this part here, when we factor that out, when we factor out 1 minus x to the power of negative 1/2, what happens is it actually cancels out. It cancels out the exponent 1/2. If we divide that out, it's like saying 1 minus x to the power of 1/2 divided by 1 minus x to the power of negative 1/2. So in fact, it becomes 1/2 plus 1/2, or it becomes 1 minus x to the power of 1. And then for when we factor out the 1/2 from 4, it becomes 8. So in fact, you notice we actually managed to deal with that the exponent there and get rid of it. So it actually simplified things a little bit. So if we can, we always want to factor out the fractional exponents if we have one. Now for the second group of brackets, let's see what happens there. So for that one, when we factor out 1/2, let's see, we have negative 1/2 there, so we can just turn that into negative 1. And then we factor out the 1 minus x to the power of negative 1/2, so that just goes away. And then we have that 4x plus 1 left over, and we just multiply all that together. And then we have that minus in the middle. So from here, now's where we get to start making this look a little bit nicer. So let's start by taking that 1/2, and we're going to move it down to the denominator. So that becomes the 1/2 at the very beginning. It's going to become a 2. And then the next part, let's move this part down. And then we just take that, we move it to the denominator, and we get rid of the negative exponent. So it becomes 1 minus x to the power of 1/2. And then we leave the 1 minus x that was originally in the denominator where it was. And then up in the numerator, all that's left is all the stuff inside the square brackets, which is 1 minus x times 8 minus 4x plus 1 times negative 1. So that's going to be 8 minus 8x. Let's see, the minus and the negative 1 cancel, it becomes a plus 4x plus 1. In the denominator, we have 2, then we have 1 minus x to the power of 1/2 times 1 minus x. That's just your exponent rules at play. That becomes 1 minus x. 1/2 plus 1 becomes 3/2. And then, next step, let's take a look at the numerator again. Let's combine the like terms. We have 9 minus 4x over 2, and we could write this as is, but since the original function had a square root instead of exponents, let's rewrite that. So let's do square root of 1 minus x cubed. So the solution's a little bit complicated and a little bit hard to digest, but that's essentially it. So if you're looking for the derivative for this function, 4x plus 1 divided by root of 1 minus x, that's how you do it. And you get this function down here. So hopefully you won't see problems that complicated too often, but if you do, now you know. Happy practicing, and I'll see you in 4.11.